discussion among with our friends. Okay, let us start.
Good morning all, myself Asif from second A. In thermodynamics we have three types of system, and as we discussed in previous class, can anybody explain the first type of system from here? JD, can you explain the first type?
Open system.
Correct answer. Next, second type of system, anyone can explain?
Closed system.
Then the final type of system, can you
Isolated system.
In this, there are three types of system in it. As our students have said that closed, open, and isolated system. In this system, if there are two categories where mass and energy. Where in open system, if mass and energy were going out of the system, it is called as open system. Next, the closed and isolated system will be explained by Mayush. If the mass suppose comes from the mass moves outside and the energy comes in, it is known as closed system.
Both the mass and energy will not exist. It's called as a isolated system.
So here we have discussed about the three types of system. Here in open system, mass remains but energy goes outside. Okay, both is going outside. Can anyone tell me? Have a clarification on that? Give an example for any open system where mass and energy goes out of the boundary. Tell me any real-time examples. Anyone can tell. You can also tell. Boilers. Boilers is an example for open. Why? Mass and energy. What is the purpose of boiler? Can you tell? What is the purpose of a boiler? Where they are used? In thermal power station, we are using boilers. Okay. So, what is the purpose of boilers? Is convert water into steam. So, when it is heated, what happens is when heat is supplied, what happens? So, water is converted into steam. So, that steam is coming outside. So, the heat energy plus the mass is coming in the form of steam. So, this is coming into the open system. Okay. So, what about closed system? Mass remains inside, but energy only crosses outside. Can you give me an example for that? Binding. How binding can be classified as closed?
Chemical energy to mechanical.
Okay.
First of all, the petrol fuel going inside to the engine and combustion of the force of also working. After that, we have power. We to travel one place to another.
So what we are saying is, but it does not come under closed system. The example is correct, but the system is not a closed system. Because in the closed system, whatever the energy it is sending inside should be remaining there itself. But here it is exhausted towards the exhaust silenced towards the atmosphere. So mass should be remains inside. So already we have discussed that if you take a cup of coffee, what happens? A hot cup of coffee when it kept on a table, what happens is we can leave it for 10 to 15 minutes. So what happens is after 10 to 15 minutes, what we can observe? Can anyone tell me? Tell me what happens when a hot cup of coffee is kept on a table. After we leave it for 10 to 15 minutes. Okay. After 15 minutes, if you come and see, what you can observe? Heat is reduced. So how heat is reduced? Where does the heat goes? By the air, it takes absorbs the heat by. Okay. So is the amount that the volume of the coffee is reduced or tea is reduced? No. So the mass is remaining same, but some amount of energy is taken outside. So in our case study on first law of thermodynamics, so here we are having what is the first law is Q is equal to del U plus W. Okay. So we are going to discuss that when Q is supplied, heat is supplied a system, what happens to the internal energy and work done. Okay. So this is our case study on first law of thermodynamics. This will can be applied for the in the real time. Okay. So here, based on the law of conservation energy, the amount of heat supplied, okay, is equal to the amount of work done. Okay. So based on this law of conservation of energy, this first law of thermodynamics is applicable for all the systems. Okay. So in all these systems, whether it's an open system or it's a closed system or isolated system, this first law of thermodynamics is applicable.